Welcome to today's webinar for the Working Group on Social Science and Humanities. We are concentrating today on how to engage with society and build public support for geothermal energy. And just a short outline for the meeting. Here we go. So first, I'm going to give a short introduction on the Working Group on Social Science and Humanities and on the ETIP in general. And then we have two presentations today. One, socio-environmental conditions for the implementations of geothermal district heating and cooling networks in Europe from Alessandro Sciullo. And then engaging schools and communities in geothermal monitoring, a case study from the DeepStor research infrastructure from Jérôme AZZOLA. And then we can still have a bit of open discussion following these two presentations. So as I said, I'm going to give a short introduction to ETIP Geothermal. So ETIP is European Technology and Innovation Platform on geothermal. It's an open stakeholder group which is endorsed by the European Commission under the Strategic Energy Transition Plan, the SAP plan. And it has the aim to combine both the research part, but also the industry, so that we have really the whole sector coming together and bringing together geothermal technologies and enable geothermal to reach its full potential everywhere in Europe. We have also the Geothermal Fora project that supports the activities of the ETIP Geothermal, and actually also the Geothermal Implementation Working Group, which is a group where also members from ETIP, EJEC, and the member states come together. And this project also, kind of supports the activity and especially the secretariat of ETIP Geothermal. The main previous achievements of the ETIP Geothermal were in 2023, we updated the strategic research and innovation agenda. So it's a strategic plan for research and innovation of the geothermal sectors. It defines some priorities in the upcoming decades and was established through data collection from the working groups of ETIP Geothermal. We had a public and wide dissemination among the member states and the EU institutions. And then we have the vision for geothermal horizons from cities to regions, which was published last year in September, and also again outlines the potential of geothermal energy and what we could achieve if we really foster the implementation of geothermal energy technologies. Showcases some examples of geothermal cities like Munich and Szeged and Paris, but also regions like Tuscany. What we have also seen that we want to increase the importance of social science and humanities also within the ETIP Geothermal. So we recognize really the importance of social science and humanities in increasing the share of geothermal technologies and the internet connections of civil society as a whole to be taken into account. So that's why we opened up this working group on SSH, and within the working group, we would like to identify research gaps and really streamline efforts to be put into the research agenda, so that we can, in the coming documents, when we update again the strategic research and innovation agenda or the vision for geothermal that comes from the ETIP Geothermal, we have a stronger inclusion of SSH topics. Maybe a short reminder on the working groups from ETIP. So we have these 9 different working groups now, and here now SSH is it's the 9th group that was recently added. We have already identified a few topics, but we would also sharpen a bit the focus of the working group and collect more input in the future. What are the first steps of the working group? We are currently collecting input for deliverable from the Geothermal Fora project. So this should be recommendations from social science and humanities for market acceptance. towards EU policymakers. And here we are currently in the writing process and would like to collect also a bit more input from the working group towards this deliverable. And then currently the SET plan, so the Strategic Energy Transition Plan, the Secretariat has set up 5 cross-cutting task force. So these task force concentrate on 5 cross-cutting topics that are kind of visible in all the different renewable energy technologies. So not only for geothermal, but also for other renewable energy technologies, wind, oceans, concentrated solar power, and so on. So all the different technologies. And they work on these 5 cross-cutting topics, circularity and materials for material substitution, then research and innovation for societal needs. So really here the social science and humanities part comes in, digitalization, skills, and access to market. The objective of this task force is to co-create recommendations to advance the work of the SET plan, so to really strengthen also the importance of SSH, of these cross-cutting topics, and see how the different renewable energy technologies can benefit from each other. And again, they want to make recommendations to the policy. So also here we are searching a bit for input for these for these cross-cutting topics and try to make geothermal really visible within the outcomes. With that, I would like to come to the next point of our webinar. So we are going to start with the presentation by Alessandro Sciullo. He's a researcher at the University of Turin and in the Department of Culture, Politics and Society, and has received also a PhD in sociology from the University of Turin. He's currently the joint program coordinator of the ERA, so European Energy Research Alliance joint program on E3S. So this is a clean energy transition for sustainable society work or joint program. And Alessandro is also part of several Horizon Europe projects and ongoing EU projects, and among one of them is a SAPHEA project, so that deals with market uptake of geothermal energy use in heating and cooling networks in Europe. And I guess from this project also comes a bit of the input for this presentation. And with that, I would like to hand over to you, Alessandro. Thanks a lot for being here today.
Thank you, Katrin. Can you hear me?
Yes. Okay,
thanks a lot, Katrin and Julia, for the invitation. Nothing to add about myself, just one quick point. I'm also the ERA, European Energy Research Alliance representative in one of the task force for the SET plan update, the one on societal needs, research innovation for societal needs. So in case you would like to have some more update about that task force, just get in touch. So can I share my screen maybe? I hope so, at least. Okay, can you see my screen? Yeah.
Yes, this is fine. It's not yet in presentation mode. Yes, now it is.
Okay.
Perfect.
Thanks. And as you already mentioned, yes, I will present in the next few minutes what we have done and what we are doing in the framework of the SAPHEA project for what concerns the societal aspects related to the deployment of a specific technology in the geothermal field, that is the district heating and cooling. And we mostly address the not societal aspects, I would say, from 2 different perspectives, and by developing 2 different, tools. One is about stakeholder analysis and engagement. The other is about societal readiness. Of course, they are strongly connected, but in the next few minutes, I will try to give you the taste of our work separately. For what concerns stakeholder analysis and engagement, no time to go in depth in how much and why it's so relevant and important to engage in a proper way to identify and engage stakeholders in the deployment of any technologies. But the three main reason why it's really relevant to be able to rely on effective tools for stakeholders engagement and identification is because having stakeholders on board from the very beginning of the deployment process might be more than useful to first define the problem at stake. So why we have decided and why we are trying to implement a specific technology. What are the societal needs that might be satisfied? It's super relevant for what's concerned implementation because having stakeholders on board might increase the compliance and the acceptance of the technology itself. And it's also more than relevant to identify to effectively identify output and outcomes of the project, both the positive impact and the negative impact. When it comes to stakeholders engagement in the SAPHEA project, we considered let's say the traditional three different levels of stakeholders engagement. The first, the basic, the entry level, it's about information. So being able to properly inform all the stakeholders about the project and implementation process. The second is about consultation, that is asking the stakeholders and the public to express their own view on the project. And the third is about decision. Of course, SAPHEA is an horizon project. It is not supposed to implement anything, so we stay mostly with the first two. As for the stakeholder analysis in SAPHEA, we developed a methodology and tools to go through the three main steps of the stakeholder analysis. That are the identification, description, and prioritization. Well, I don't know if it's correct in English, but anyway, so to identify who are the most relevant stakeholders and why. And we developed two main, very easy to be used tools, an Excel-based tool for qualifying, describe the stakeholders, and a diagram to qualify and to prioritize and to cluster the stakeholders with the objective that I already mentioned in the previous. So what is a stakeholder here? A bit of references about the concept about stakeholders. In our case, in SAPHEA, stakeholders is anybody, collective of individual actors that might affect or might be affected by the project, in the specific case by DHC, GeoDHC implementation. How we addressed the challenge of identifying stakeholders is by delivering questionnaire questions and questionnaires about the description of the project. First of all, because in order to identify who are the relevant actors in a process, whatever the process, the first I say priority is to have a clear idea about what the process actually is, how the process actually is shaped, what are the main components. So we developed a guideline, I'd say, in order for all the implementers and promoters to be able to address all the relevant components of the project. So this is about stakeholders related to the, say, features, specific features of the project. The second is about implementation chain. Again, the stakeholders might get in and get out from the process depending on the steps of the deployment process. So in addition of being very super relevant, having a clear idea about the project itself, it's also important to address all the implementation chain because different stakeholders might be affected in different ways at the different stages of the deployment process. Some of them can be affected or involved in the inception and planning phase, some others in the implementation phase, some others will be affected at the very end. For example, in the first could be just engineers, companies, and partially also the public administration in the field. For the implementation, of course, the main stakeholders are all the governmental bodies that might authorize the public works, might be private and public association that could enter as provider of services the implementation process, and for the outcome and the impact is the whole society. So these are other guiding questions to identify properly the stakeholders. And here is the more than traditional categorization of stakeholders that we proposed to our partners to adopt for the stakeholder analysis. Why we proposed? Because at the end, we had a number of case studies in the SAPHEA project all around Europe, 5 to 7, depending on the maturity of the process. And we actually applied these tools and methodology to our 7 case studies. So we identify different features for describe the stakeholders to be considered and addressed. And again, for each of these features, we deliver and we prepare guiding questions. Of course, now we don't have time to go in depth in all of these features, but for each of them, I will go really quickly. For each of them, you will find in our, say, deliverable, all the guiding questions to properly address the different features of the stakeholders, their role in the process, how and to what extent and how they could be impacted, which resources they could have to affect the process. So they could be political resources, financial resources, knowledge resources, or whatever. How much power do they have for impacting the process, to hamper or to support the process, and to what extent they are interested in, let's say, exploiting their resources and affect the process. And, well, one slide maybe is missing. Based on the description of the stakeholders, so the analysis of the stakeholders, we then move to the categorization. In particular, by considering the interest and the power that they have. This is a super traditional, very well-established in literature approach to the stakeholder analysis that allows to identify and to cluster the different stakeholders in 4 main groups. For any use, the promoter, implementer deem relevant. And the 4 main categories based on the power and interest that they have are the key player, the so-called key player that are stakeholders with a lot of power and a lot of interest to affect the process, are the context sector, in general, the public administration, or one of them, that are super powerful, but not always interested, but still they can make a difference in say, providing the right environment for the development. Then we have the subjects that are the people, let's say, and in general here is the general public, the people that are most affected, very interested, but don't have that much power to affect the process, and then you have all the rest. Why it's important to identify this cluster? Because for each of these different categories, different communication and information strategies might and should be adopted, and different engagement strategies should be adopted at different stages of the project. So this is how we work in SAPHEA for the stakeholder analysis and prioritization. Here, our friends from Poland provided a super stakeholder analysis, but it's always a pleasure to share. Here with some, this is the first part about the description of the stakeholder. So for each of the categories, of the features that I mentioned before, you find how they evaluate the different features for the stakeholders, and based on the interest and power on the score, this is the prioritization. Of course, here's the number and not the name. So the result is for the stakeholder analysis in Poland, that we have a lot of quite a small number of key players and a lot of people that might be affected, quite a number of crowd, that means actors that must be kept informed but are not so relevant. It's a bit weird that we don't find context sector, but maybe because it's the specific institutional framework in Poland that in a way produce or trigger this this shift from the context setting to the key player. That means all the context testers are also very interested in the deployment. So this is about the stakeholder analysis and identification. And now let's move to the societal readiness. That is the second, let's say, component of our effort to address the social or not technical aspects in the SAPHEA project. The societal readiness, I guess that you know even better than me what it is, because in my view is still a bit of confusing concept, but it is gaining a lot of attention in the policy and scientific communities. So societal readiness is in any case, whatever our judgment about the robustness, it's an innovative way to try to address and to assess the extent to which a specific society or specific local communities is in a way ready to accept, to implement, to adopt a specific technology or project. What I find really interesting and potentially very powerful in the societal readiness framework is that it's also true the way around. That means we have two main questions. One is about how much society is really ready to accept the technology. The other is, from the technological perspective, to what extent technology is ready to be implemented and to be adopted without affecting too much the recipient communities. So societal readiness, it's really a powerful concept, is still to be developed and operationalized. That's why it's important. Being new, as I write here in the slides, it opens, and that's why it's so interesting, a lot of space for research, discussion, and application. This is the first reason. The second reason is that the group, the work group in Denmark, of the Denmark Fund, that proposed the societal readiness approach, also identified by mimicking the technological readiness level, identifying 9 different societal readiness levels. It is nice to have this kind of references, but still it's an open issue, an open question, an open room to be explored, how this different societal readiness level can be operationalized, that means measured. So we know what do they mean, but it's not always clear how to be implemented. Again, a lot of room here to work on the societal readiness. The third, last but not least, is that the European Commission, as you might know, is putting a lot of attention, effort, and also money, if I may, on the societal readiness. We have in the Horizon Work Program in 2025, 8 calls on societal readiness. And in a way, we are working, and also in the framework of the European Energy Research Alliance, in trying to address these goals. So we are trying to create work groups that could also submit successful proposal in order to be funded to explore, to exploit more the societal readiness level within the Horizon framework. Said all that, why so important? How we implement it, adopt it. So we made an effort to simplify a bit the societal readiness levels, and we narrowed down to 5 main levels. From the first, that is about the very basic identification of stakeholders, communication, and evaluation of environmental social impacts, to the 5th, that is where the promoters, implementers were able to put in place all the needed tools, methodologies, and effort to have a clear idea about how the society could react and how the society could be benefited. So we simplified a bit, and these 5 levels have been replicated on the 4 different dimensions of the societal aspects. One is about stakeholder identification engagement. The other is about public perception, then environmental impact, and social impact at the end. So for each of these domains, you have 5 definitions of the societal readiness level. And for each of them, as for the stakeholder analysis, we developed an easy-to-be-used questionnaire to assess the societal readiness level. It's a bit long, but in short, means that we released a questionnaire, a multiple choice questionnaire, that not only gives the promoter, implementer, or whoever is interested the opportunity to explore the different dimensions, but also to assign a score. That means to measure at the end to what extent the society is ready for the new technology and the technology is ready for society. So that's all in a way. I don't have anything else to be added here. And I hope not to have been too long. I would say no. And I stop here. And with many apologies, because unfortunately I need to start a lecture in a few minutes. So Katrin, I'm terribly sorry. I can't wait until the end of the webinar for questions.
Okay.
And so if anybody should have any question, please, here I am.
Are you available for 5 more minutes for questions?
Yeah.
Yeah. Okay. So thanks a lot, Alessandro, for the presentation. A big thank you. Do we have questions from the audience? I'm not sure, Julia, can people just unmute and ask questions? Or do they have to post them into the Q&A tool?
They will have to use the Q&A.
Okay. So if you have questions, please post them into the Q&A and I will read them out loud. Maybe already a question from my side. You talked about the society readiness and this difference between is society ready for the innovation and is the innovation ready for society? Would you say that if you have two different technologies that are equally ready for society, there could still be differences in the society being ready for each of those?
Wow, good question. I would say yes, depending on the society. By society, I mean depending on the societal context where the technology will be implemented. I mean, we could have the most suitable technology for addressing any societal needs, but at the end, the acceptance, the impact might, or for sure, differs a lot depending on the socioeconomic institutional context where the technology is deployed. As for any other project or policy, it's really hard to generalize. Of course, we could have, I mean, we could pay attention when developing or designing technologies to have the perfect technology, but the one really good practice that should be more considered by the implementer, promoter, engineers is to include the society in the designing process. It is another stream of literature about responsible research innovation, but still this is the challenge.
Yeah. Okay, great, thanks. There's one question from the audience. Is a survey for defining society readiness levels open and available?
Yes. It's on the website of the project, SAPHEA project. I forgot to put the link on the slide, but I don't know if I'm expected to share the slide. I can share the slide with all the link. If you go to the SAPHEA website, you will find deliverable 5.2.
Okay, great.
In any case, I don't know if I was allowed to, but I put my email in the chat if any other question might raise in the following of the webinar.
Okay, we have one more question. What is the best strategy and in what institutional moments it is best to involve stakeholders and ask people to answer questionnaires? Or is the strategy different depending on who is a stakeholder?
The second, that means the stakeholders, depending on the stakeholders, of course, the general rule is to involve as soon as possible in the process. But still, the stakeholders are very different and not all of them must be involved at the same degree of involvement from the very beginning. Some of them can be kept informed and involved in the following step. What is super important to engage from the very beginning, and this is connected to the co-design, is the general public. The general public, when it comes to infrastructure, when it comes to project to be deployed in a specific territory, the general public, the local community must be involved from the very beginning. And as for the questionnaire, well, the questionnaire should be, well, the questionnaire that we developed is more for the promoters, implementers, is more for supporting the analysis of the stakeholders. And when it comes to the engagement, involvement, contact, getting in touch with stakeholders, the tools should be really customized depending on the stakeholders. The one that you find in the deliverable is just the analytical methodological tool that we developed for promoters.
Okay, great. We have a question from Leonie Kuhlmann. Thank you very much for the interesting presentation. Have you considered to include a more economic angle to measure SRL as well? So a six level probably, as it also impacts society?
Good question. In a way, well, it depends on what we mean by economic. If it's about the economic impact on the recipient communities, or so that can be lowered or increased, it's already there in a way. If it's an economic impact intended as the revenues for the companies or for the promoters, or taxes for the public administration, is not there and could be included. But I mean, I think economics must be included to the extent that we can consider economics as a kind of subtypology of societal aspect. That means affecting quality of life of people and affecting the opportunity, the capability of people to act. And that's it.
Okay, and then we have one last question. In Switzerland, one survey in Jura Canton last year found 73% of people opposed to deep geothermal, and they give reasons such as risk and dangers, seismic activity, environmental damage. Do you agree there's a lot of work still to be done to improve public perception of geothermal? Well, I guess the short answer is yes.
Yes. Yes, when it comes to the opposition to such impacting project, it's not only about how this project actually affect the territory and the local communities. It's also about more, say, abstract values like environmental values and even political attitudes. And so sometimes even, I mean, it's more than legitimated, or how to say, sometimes the opposition comes from other reason than just the impact on the territory. It's about opposing or proposing alternative to model of development and energy transition. So I'm against deep geothermal because in my view, not me, of course, but because in my view, it's part of a policy that is far from what I think should be a sustainable energy transition policy. Not extract again from specific territory, but an alternative. So in opposing the geothermal, the specific project, many different factors might be affected. I'm not sure that a more detailed and customized information can make a difference, because science speaks a language and the general public speaks another language. Find a common language, it's, I mean, not only tricky, but it's almost an impossible task to be properly addressed. So it's a bit, it's not just a matter of informing. Of course, the better and the more we inform, the better. But still, the solution is not just about giving more information. Maybe we need to refine, to find the right language, to find the right, to convey the right message. But still, it's not just a matter of informing. It's, I mean, to consider many other aspects that might trigger opposition. Okay.
Yeah. Thanks a lot, Alessandro. Thanks for for the discussion, Katrin, and your presentation. And then I would like to switch over to the next presentation.
And enjoy the rest of the work.
Yeah, thanks.
Okay. Actually, this last discussion was a good transition to my presentation, I think.
Yeah. So next presentation is engaging schools and communities in geothermal monitoring, case studies from the DeepStor research infrastructure by Jérôme AZZOLA and Judith Bremer. I give a short introduction. Jérôme is research associate at the Karlsruhe Institute of Technology in the group of geothermal and energy and reservoir technology. Oh, sorry. He received a PhD in geophysics from the University of Strasbourg. And Judith Bremer is also a researcher at the KIT. She got a PhD from the LMU in Munich and is working now a lot in context of these large-scale demonstration projects at the KIT, especially at the DeepStor project. And I think Jérôme is going to present now. Thanks a lot for accepting the invitation.
Can you see my presentation?
It's not yet there, but it's coming. Now it's here. Yeah, perfect.
All right. Katrin, many thanks for the invitation and for the nice introduction. So as you said, I'm a geophysicist working as a postdoc at KIT. So my work is at the interface between seismology and deep geothermal energy. I'm especially interested into seismic monitoring of geothermal projects. And I have been also interested in recent years into public outreach and citizen science with also my colleague Judith Bremer, who joined the webinar as well. Voilà. We will start with some background, then go through the concept we develop in our projects and detail some case studies finally. So we are located in Karlsruhe in the Upper Rhine-Graben, a geological environment known for significant temperature anomalies, and the region has also strong potential for geothermal energy, and there are several ongoing or planned projects in the vicinity. And our initiative focuses on the Helmholtz research infrastructure called DeepStor. This infrastructure investigates the concept of aquifer thermal energy storage directly on the KIT campus north. It is planned because the drilling of the first exploration well is planned for the beginning of next year, so 26. We are currently in the preliminary phase of the project, and this work is carried out in that context. The campus can be seen actually as an urban environment with highly sensitive facilities because of the research that is going on there, and acceptability is a key aspect. So the symbols here, they simply show our measurement sites, which I will introduce later. So the motivation for this work is that geothermal projects can face a negative public perception. That's not new for you, probably, which is a true reality in our region, the Upper Rhine-Graben. This opposition and lack of acceptance is mostly visible at the local level, and concerns often resolve around induced seismicity, which plays a key role in the social acceptance of geothermal energy. There is the influence of a few cases of induced seismicity felt by the population in this region, which are associated with fears of recurrence and a potential source of damage for buildings, for example. This lack of acceptance can also be connected to unadapted communication of scientific complexities, mistrust, ineffective dialogue, limited opportunities for public to engage in these projects. And our work tries to address this by transparent and active exchange with the citizens and by involving the citizens into the geothermal research. The concept we are developing within DeepStor is based on a multi-level and multidisciplinary approach, including geophysics and geosciences for the content and social sciences for the development and evaluation of these formats. So the aim is to promote transparent and participatory interactions between researchers and society. This is done through different formats that propose also different levels of interaction between research and citizens. We develop, of course, lines of communication, but they are mostly passive for the citizens, and the engagement or the communication goes in one direction. We also want to get closer to the citizens and get their feedback, develop formats together. This type of dialogue is carried out through open discussions and school projects, which I will illustrate in a few slides. And finally, stronger interaction can be promoted through co-design and co-creation formats. There was a project called GECO. It was a co-design project at KIT that was carried out a few years ago and involved members of the municipalities around Campus North. These citizens were involved in the development of youth concepts for heat supply of the KIT campus. And participants also expressed a need for communication and transparency, also with regards to monitoring data. So participatory seismic monitoring can help to meet this demand. Participatory monitoring requires, of course, the use of instruments, and we want to involve citizens in geophysics using Raspberry Shake 3D seismometers. So I brought one here as well. It's a relatively compact 3-component sensor. It includes actually the data logger and the sensors in this relatively compact size. It's relatively easy to use for the end users based on a Raspberry Pi Linux platform. It's also relatively cost effective. There is a 10-time ratio, let's say, between a Raspberry Shake and standard professional instruments. This means that several units can be installed for the cost of one single. And the data are also open access from all connected stations worldwide for data visualization. And the platform also proposes some data processing workflows. And on the other hand, it is also known to be less sensitive than state-of-the-art seismometers. So that's the constraint mainly that we have to deal with. An example of our initiatives we are deploying to engage in a dialogue with the public is this exhibition that was held in February for 3 days in the city center of Karlsruhe. So the focus was on the research being done within DeepStor with 5 booths, each presenting a specific scientific aspect of our research. There was one booth on seismic data acquisition and seismic monitoring, where we showed, for example, different types of instruments. And the Raspberry Shake was used as a way for people to better understand how we record ground vibrations, the origin of these ground vibrations, and how it is part of our monitoring approach. We also use small experiments to teach participants about rock properties, such as permeability and porosity, which are important for us in geothermal energy. And to give the participants a better sense of geology, we also invited them to take part in a VR excursion underground, exploring the properties of the different geological units all the way down to the targeted reservoir. So the goal of these activities is to bring science closer to the public, and there was also a focus on evaluating this format. As part of these initiatives, we also try to survey the participants to evaluate the format and its future development. This is done through questionnaires on a tablet, carried out before and after the visit, typically. And typically, participants are asked to self-assess their knowledge of various topics, such as here, their knowledge of deep geothermal energy technologies, but also seismology and other topics. Here is the distribution of answers before dialogue, after dialogue, with the red showing the mean and the median in blue. And in that particular case, we also assessed their interest in participatory monitoring. And it shows that the interest increases after discussing the details with us in the exposition, which simply underlines the importance of communication, especially with little known technologies, such as these seismometers. School projects are another format that we develop, and that allows for an even stronger interaction with pupils in that case. We carried out such a project with a small group of students from a school in Bruchsal, located next to the geothermal plant of Energie Baden-Württemberg. So to increase engagement with these pupils, we designed the project in the form of a role-playing game, where the students took on the role of seismologists working for the geothermal plant. And their task was to find the most suitable location for a new seismic monitoring station. That is to say, the one with the lowest ambient seismic noise. And the project consisted into 5 modules covering an introduction or training, then the field work, where each group of students was installing a station, 5 in total. Then the data were collected and analyzed together using a workflow based on Python scripts that we developed for them. And the final workshop was also organized for them to present and discuss their results. So from an educational point of view, such project is also quite useful and interesting, because it includes different tasks that can also develop a range of competencies. And it also produces geophysical observations. As I said, we tested 5 sites, 3 in the school, especially 1 in the garden of that school, 1 near a main road passing by the school, and 1 inside the geothermal plant. Seismic data were collected over a couple of weeks and analyzed both visually by observation of the waveforms and correlating, for example, strong amplitudes with the effect of a parental evening at the school, and also statistically for a more robust comparison of the behaviors. And as you can see here, the conclusion was that the station in the garden provides the lowest level of ambient seismic noise. And such an analysis actually reproduced in different locations, schools, could also contribute to microzonation and the assessment of site-specific effects. And the project was also evaluated on the basis of questionnaires carried out before and after the project. As for the exhibition, we use self-evaluation for the assessment of knowledge. And what is actually quite interesting here also is to see that a large part of the group was actually not aware before the project of the geothermal site next to the school. Overall, the project, I would say, contributes to their understanding of the topics covered, and the hands-on learning format makes it also quite attractive for these pupils. And in terms of post-project impact, it was presented and promoted at the local level of the school, but also at the national level, and the students were also able to enter their achievements in a school competition. All of this contributes also to the multiplication of knowledge and awareness and that the project aims to achieve. This first project was, this first school project was a first test that we carried out, I think 2 years ago. And now we are going to reproduce it again in another school. So this brings me to another format we are developing, which is the collaboration between citizens and science, with the goal here of distributing and installing sensors such as the Raspberry Shake in a radius of, say, 10 kilometers around the North Campus, and involving the citizens into the geophysical observations as a complement to standard seismic monitoring practices. This is something we are currently developing, which also takes time to implement, and I will first focus on the concept. This can actually be done through different formats, ranging from the pure participation in data collection, which is quite passive for citizens, to more complex citizen science initiatives. And at the moment, we are more at the level of participation, where the citizens collect data and have access to it. But our goal is to move towards citizen science initiatives. And I think an important aspect is especially the interpretation of data and the development of adapted tools, where we see a need to develop such citizen science initiatives. One main issue for the general public might be the understanding of the complex data sets they would have access to. And for example, here I showed a screenshot from the Raspberry Shake website, where the data sets are published and freely available. We can see the waveforms, we can see also the spectrum, but without any further explanation, these high amplitudes here could also be interpreted as a hazard, like an earthquake, and we need to avoid misunderstandings, and this can be achieved by developing specific digital tools with citizens to guide public understanding. And one idea would be, for example, here to implement pattern recognition to identify the source of these transient signals observed in the data segments when applicable. The potential benefits of such actions are threefold, I would say. It can advance science by providing access to a larger, denser network for carrying out scientific observations, as I will show, and mainly because these Raspberry Shakes are cost-effective and can be deployed in large networks. By involving citizens in our science, we also promote dialogue and participation, increasing transparency, which could also address issues of public perception. And as a result of the collaboration, the public would also gain knowledge and hands-on experience in the related topics, be it physics, geophysics, or geosciences, fostering therefore also more informed opinion making. Just to illustrate the current status within the DeepStor project, we installed 9 sensors on the KIT campus north and nearby, focusing on collaborations with institutes and colleagues. These are these Raspberry Shake symbols here. We provide guidance for the installation of the sensors and training for data visualization on this Raspberry Shake interface. And as I said, this work should be extended in the future to citizens around the campus north, now looking for interested citizens. And interestingly, this existing sensor network can already prepare the seismic monitoring of DeepStor. Here I report also on some geophysical observations based on noise measurements using these 9 Raspberry Shakes, with the idea of assessing the capabilities of the network of Raspberry Shakes. This means that from the measurement of power spectral densities, we evaluate the minimum the minimum magnitude detectable by the network for seismic events, here having an origin at the reservoir depths of DeepStor. And the results here actually suggest that the network of Raspberry Shakes could contribute to future seismic monitoring of DeepStor, which is planned to be based on these 5 seismometers here. I finish with some quick conclusions and perspectives. So within this pre-phase of the DeepStor project, we explore various formats to engage with citizens with various levels of interaction between science and citizens. We show that these Raspberry Shake seismometers can actually serve as a central tool for fostering dialogue and collaborations between the science, the research, and citizens. Yes, we show that the collaboration with citizens is starting within this DeepStor project and should be upscaled in the future, which is bringing me to the perspectives. So we want to actively involve a broader range of citizens into the seismic measurements, having more interactions with the citizens, for example, in the development of digital tools for data visualization. And a perspective from the geophysical standpoint is also to integrate this Raspberry Shakes data into standard seismic monitoring practices. And with that, we hope that we can provide guidance for a successful integration of these initiatives into future geothermal research and industrial applications. Thank you for your attention. And if you have no questions, I will be here.
Yeah, thanks a lot, Jérôme, for the presentation. Very interesting. I again ask people to post their questions into the Q&A tool so I can read them out loud. I would start with the first question. Did I understand correctly that the data from the Raspberry Shakes is always openly accessible? So as soon as you have
tuned,
such
actually.
Sorry?
It can be tuned. It's when you buy this Raspberry Shake, you give also the license to the company Raspberry Shake that they can have access to your data on the data you collect, and the streamline for every Raspberry Shake that is connected to the internet goes towards Raspberry Shake, the company that is providing access to this data online, so freely accessible to everyone. But this can be tuned in a way that this Raspberry Shake also work offline.
Okay.
So yeah.
But in principle, it should also really increase the trust between the operators and the citizens, right? I mean, as soon as people can see really the data from their own garden online, they kind of have a bit of more control what they see.
Yes, exactly. I think that's what we target. But then, yeah, the true social impact of such initiatives, I think, needs still to be assessed. And yeah, on the downside, unfortunately, we cannot provide a Raspberry Shake to every citizen around the KIT Campus North in a radius of 10 kilometers.
Yeah.
So it stays a little bit targeted, I would say, in terms of impact.
Mm-hmm. And maybe one more question, a little bit more on the technical side. Did you observe during the school project already real microseismic events? Or was
No,
this
no,
not?
absolutely not.
No.
Bruchsal is not seismogenic at all. So there is little chance to observe an earthquake.
Mm-hmm.
Be it regional, at a regional scale or at a local scale. So no, unfortunately,
Yeah.
no microseismic event, just ambient seismic noise to be processed.
Okay. Yeah, thanks. So do we have other questions in the chat? Now I see something. A question from Roman Seidel. How to communicate uncertainties in measurements, etc., especially when there's mistrust?
Yeah, that's not something that we addressed so far in our studies, but definitely it's fully relevant, because even if we provide access to this data, there is still the question if the citizens will believe in what we say. And I think, for example, if we provide access to processing results like magnitude, PGV, peak ground velocity, peak ground acceleration, and stuff like this, involving the citizens into the processing of this data would be a solution or a way to increase the trust in the results that we provide. But this is not easy, because definitely these values need to be explained in the proper way, and the way we get them is also not straightforward for the general public, I would say. So there is a lot to do on this topic, I think, and I agree.
Mm-hmm. But did you observe this in the area, that people really mistrust the results that were given, for example, by geological survey or whoever does the seismic monitoring in the, I mean, not only for the DeepStor project, but maybe in general for the Upper Rhine Valley?
Personally, no, but maybe Judith can comment on that. I don't think, oh, well, personally, I didn't observe anything like this.
I mean, in the DeepStor project, when we did this co-design project, we observed rather the contrary. That in the region directly around the KIT Campus North, there is the people generally trust in KIT. So doing a geothermal project there, we have an advantage compared to other cities, I would say. But yeah, in personal communication with people in other cities, we did the experience that there is distrust and they do not believe anything. And yes, this is definitely an issue.
Okay, yeah, thanks. I do not see other questions for the moment. So unless there's something popping in a few seconds, we are already almost, we are already on time with the webinar. So yeah, I guess then it's time for me to thank you all for presenting and also for answering the questions. And with that, I would like to close the webinar. Thank also all the participants. I think it's not possible to have a more discussion now, but we would soon organize also another meeting for the working group, and then get a bit more into the discussion of the topic once more. Yeah, thanks a lot, Jérôme and Judith, and also especially Julia for setting everything up.